بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 1.5 and it's about solutions of systems of linear equations. We will talk about three different solutions. First, three ways to solve systems of linear equations. First, graphical solution. We can use a graph sometimes to get an accurate solution. Sometimes it's not possible to get the accurate solution using graph. Well, this is an example. Use graphing to find the solution of the system. So usually we talk here about linear equations. So we will have two linear equations. The graph of the first equation would be a straight line, and the graph of the second equation would be the straight line. And the point of intersection would be the solution of the system because it will satisfy both equations. If you remember, to graph the two equations, first let us start by the first one. We can just choose 2 points to graph the line. Let us choose the x-intercept and the y-intercept of the first equation. So if we put 0, if we put x 0, y would be 11 over 3. And if you put y 0, then x would be 11 over 4. Well, these numbers are not that good. Okay, it's not easy to graph, to plot 11 over 3 accurately, but we will try. For the second equation, if x is 0, y is negative 1 over negative 5 or 1 over 5. And if y is 0, x is negative half. So let us try to sketch the graph. We need, you can approximate 11 over 3 by the calculator. So it's almost 3.7, okay? So 0 and 3.7, this is 1, 2, 3, 4. So this would be 11 over 3. That's the y-intercept of the first line. 11 over 4, check by the calculator, it is 2.75. That's the x-intercept. So it's somewhere here. So you can connect the two lines, okay, the 2 points, sorry. So this is the graph of the first equation. The second equation, 0, 1 over 5.2, this is almost the y-intercept, and negative half and 0 is this point. So this is the second line. Now try to figure out this point, okay? Of course, I'm using my hand. If you sketch the graph accurately, you may get this point accurately, but it seems that the x is 2 and the y is 1. So I think this point is 2 and 1. We can check the solution. Is this a solution of the two equations? So x is 2, y is 1. And let us replace in the first equation x by 2, y by 1. So it satisfies the first equation. In the second equation, 2 times 2 is 4, minus 5 times 1 is negative 5. Actually, it satisfies both equations. So the solution set is 2 by 1. But you notice that anyway, we have seen from here that if the two lines intersect in one point, then this system has one solution, unique solution. If the graph of the two equations are parallel lines, so they will have no point in common, parallel lines like this. there will be no intersection points, then the system has no solution. Such system is called inconsistent. So inconsistent systems have no solutions. The two lines are parallel. For example, these two equations are represent two parallel lines. If you graph them, you will find that. Or if you try to solve or to write the first equation, for example, in the slope intercept form, so you will find that y is negative 4 over 3x plus 4 over 3. Here also, if you write it in the slope intercept form, you will notice that y is negative 8 over 6 or 4 over 3x plus 18 over 6, or 18 over 6, or just you can divide by 3 both sides. 18 over 6 is just 3. 3 times 6 is 18. So the answer, the y-intercept of the second line is 3. You can see that the two lines have the same slope, which is negative 4 over 3, but the y-intercept of the first line is different than the y-intercept of the second line. The two lines would be parallel. Also, if you want, this is another way to graph the lines. You can sketch the graph of the line using the slope intercept form. So for example, the first line, the y-intercept is 4 over 3, so it is here 1 and 1 over 3. And delta x is 3, so you go from this point 1 to 3. Let me take the same unit of measure, this 1 2 3. 3 units to the right. This is the change in x. The change in y is negative 4, so you go below. This is 1. I go 4 units, 1 2 3 4, but it was here, so I reach this point, and this would be the graph of this line. The second one, y-intercept is 3. Also, I go 3 units and 4 units and sketch the graph of the line. And if your graph is accurate, these two lines would be parallel. So if they are parallel, the system is inconsistent and the solution set is phi because there is no point of intersection. Sometimes the two equations will describe the same line, okay, the same line. So when this happens, we have one equation and it intersects itself in infinitely many points, the same points of the line. So we will have a system of infinitely many solutions, and we call the system dependent system. Okay, so all points of the equation will satisfy, will be a solution in the solution. So for example, here to find out that the two lines are equal, you can always try to write them in the slope intercept form, or if you look just carefully, 4 3 4 8 6 8. So actually, if you divide the second equation by 2, you will have 4x plus 3y equals 4, and this is exactly the same, the first equation. In this case, we can write the solution like this. Solution set will consist of all ordered pairs x, y, such that this ordered pair satisfies the first equation or the second equation, because in fact we have the same equation. So we just say that the solution of the system would be all ordered pairs that satisfy the first equation. So this is the method by graphing, and as you can see, we can't get an accurate solution most of the time. But at least we know now the three different types of possibilities. Either the solution of linear system either consists of a unique point, which is the point of intersection, or no solution if the two lines are parallel, or infinitely many solutions if the two lines are coincide, I mean the same line. The method we use usually algebraically, we have two methods algebraically, so this will give us the exact solution. Solution first by substitution. Before using the method, let us define what we mean by equivalent systems. Well, systems would be equivalent, which means they have the same solution if one expression is replaced by an equivalent expression. Okay, if you replace equivalent expressions, then this will not change the solution of the system. If you interchange two equations, so for example, this system, if you write this equation first or this equation first, it doesn't matter. The system will not change. So this is what we mean by interchanging. A multiple of one equation is added to another equation. So we can, for example, here, we can add a multiple of the first equation to the second equation. So we can add -2 times equation 1 plus equation 2. Okay, we can change equation 2 by this. So we leave equation 1 as it is, but we multiply -2 times 4, -8 plus 8, that's 0. Then -2 times 3, -6 plus 6, also 0. -2 times 4, -8 plus 8 equals 0. And we get 0 equals 0. And this is one way to see that the system is dependent when we have 0 equals 0, which means one of the equations is exactly the other one. An equation is multiplied by a non-zero constant. If you multiply the equation by any number, 2, 3, 4, this will not change the system. For example, here we multiplied the second equation by half, or we divided by 2. This doesn't change the solution of the system. So we have to understand what are the things we can do in the systems that will not change the solution of the system. So we call them equivalent systems. So let us see how to solve a system of two linear equations by substitution. Well, first we try to solve one of the equations for one of the variables. Okay, so here if you look to the first equation, coefficients 2, 3 of the variables, but here the coefficient of x is 1. If the coefficient of one of the variables is 1, it would be easy to solve this equation for x. If you just take -2y to the other side, then this would be the solution for x. And now we can take this expression for x and substitute into the other equation. So we can go to the first equation now and replace x in the first equation by 2y plus 3. Then we will have an equation in one variable. We can solve this equation and get the value of y. So now we have the value of y. After that, we can put the value of y in any of the two equations, or we can put it here in this equation. In equation 1, in step 1, we can replace y by -2 over 7 to get the value of x, and now we have the solution. We can check it at the last step. In the last step, we can check that these two values of x and y actually satisfy both equations. Then this would be the solution of the system. So let us solve one question. If I look here, I have 4, 5, 3, 9. I have 3, 9, 12 in the second equation. So what if I divide the second equation by 3? Okay, if I divide the second equation by 3, I'll have x minus 9 over 3, that's 3y, equals -12 over 3, which is -4. And now the coefficient of x is 1, so I can actually solve this equation for x. So that's, I have now x solve the equation solved for x. So I can go, for example, in equation 1, I can go to equation 1 and replace x by 3y minus 4. Of course, you cannot replace x equals 3y minus 4 in the second equation. If you do that, you will get uh, an accurate equation, 0 equals 0, but you will not benefit from this. But you have to use, you found x from the second equation. Now you have to replace x by 3y minus 4 in the first equation. So we will have 4 times 3y minus 4 plus 5y equals 18. And now we can solve this equation and find the value of y. Okay, 12y minus 16. And now we have 12 plus 5, 17y, and 18 plus 16 is 34. If we divide by 17, y would be 2. Good. So now we have y. We can go back to this equation and replace 3y by 2. So 3 times 2 would be 6, minus 4 would be 2. So the solution is 2 and 2. Now you can check your answer by substituting in the two equations and make sure that 2 satisfies both equations. Or if you can use the calculator, you can go to mode 5 equations, or if you have different version, so you go to equations. There is one of the choices is solution of linear equalities into variables. So you put the coefficients 4, 5, 18, and 3, -9, and -12, and then the calculator will say x is y and 2, and x is 2 and y is 2, so our answer is correct. The second method is solving by elimination. And to solve by elimination, we multiply one or both equations by a non-zero number that will make the coefficients of one of the variable in identical, one of the variables. So that's our idea, to make the coefficients of one of the variables identical, except perhaps for signs. So for example, if you look to x, the coefficients of x, we have 2 and 1. This is the original equation. And here we have -5 and 2. Well, it is easy to multiply the second equation by -2, and then we will have 2 -2 as coefficients of x. So coefficients of x would be identical except for the sign. If you want to make coefficients of y identical, you have to multiply -5 by 2 and y 2 by 5. So you will multiply the first equation by 2 and the second equation by 5. And that's more work than multiplying the second equation only by -2. So if we multiply the second equation by -2, the first equation does not change. The second equation would be like this. And now we can add or subtract. If the signs are different, we add. If the signs are the same, we subtract to eliminate the variable x. So we will have only the variable equation in the variable y, and we solve for y, and then we go back to any of the equations, for example, equation 1, and we replace y by 2 over 9 and solve and find the value of x. And then we can check our solution. So this is the idea of the elimination method. Let us solve this application. A person has $200,000 invested, part at 9% and part at 8%. If the total yearly income from the two investments is $17,200, the question, and now that's the question, how much is invested at 9% and how much is invested at 8%? So usually the question, we give it variables, okay? So we assume that the amount invested at 9% is X and the amount invested at 8% is Y. What do we know about the total investment A person has 200,000 invested. Some of them here, some of them here. So X here, Y here. So X plus Y, his total investment. The sum of the two amounts would be $200,000. So this is one equation. Now we try to find another equation, two equations. So we will have two equations in two variables. Okay. So now the income. We have the income. The income is 17,200. Well, I know the income. How to find it? Well, he invested X amount at 9%. This means that the income of this X would be 0.09, 9%. 9% of X, this would be the income, plus 8% of Y, this would be the income of Y, equals the total income is 17,200. So these are the two equations, and we need to solve them and find the value of X and Y. Okay, if you look to the equations, well, I can easily multiply the coefficient of X here by negative 0.09, for example. So to use elimination method, or I can multiply Y also by negative 0.08. So, or if you want, I can get rid of this 0.09 by multiplying the second equation by 100. If I multiply by 100, then this 0.09 would be 9, just to have numbers, integers, not decimals. So I will do that. This is 5 zeros. Okay, I will multiply the second equation by 100. So this would be x 9x, and this would be 8y, and this would be 172, and another 2 zeros. Maybe this is better than this. Now, let me multiply the first equation by negative 9. So multiplying the first equation by negative 9, so negative 9x, negative 9y would be equal to negative 9 times the 200,000. And I will have this number, and I have 9x plus 8y equals 172 and 4 zeros. Okay. Now we can add both equations. So x will be cancelled. Negative 9 plus 8, that's negative y. And I'll have, if I add these two numbers, I will have negative 80,000. So y, in fact, is 80,000. So we know that the amount invested at 8% is 80,000, and to find x, which is the amount invested in 9,000, we just here use the first equation. X is 200,000 minus the 80,000, and the answer would be 120,000. And then you can write that the amount invested at 8% is 80,000, while the amount invested at 9% is 120,000, and we solved the question. Solve the system by elimination. Look to the coefficients. You have 4, 8, 3, 6, 4. Also, if you look to the coefficients of the second equation, you have 8, 6, 18. So I will divide the coefficients here by 2. So why not dividing by negative 2? Okay. If I immediately divide by negative 2, I will get 8 over negative 2, that's negative 4. Why I divided by negative 2? To have the coefficients of x opposite to each other. Okay. And 6 over negative 2 and 18 over negative 2, negative 9. Now, if you add these two equations, you will get 0 here, and here 4 minus 9 is negative 5. Well, 0 cannot be equal to -5. This is not accepted. Okay, so the solution set of this equation is of this system is phi. This means that the two equations are parallel and there is no point of intersection. While if we get 0 equals to 0, this is a true statement, and it means that we have the same line. So if you have two different numbers like this, it means that the two lines are parallel and the solution set is phi. Look here, I will divide by -2 again. So -4x, -3y equals 8 over -2, -4. Now, if you add these two equations, you will have 0 equals to 0. So this means that the two equations represent the same line. Actually, if we divide the second equation, or if you multiply the first equation by 2, you notice that you have the same equation. So as we said, you just write the solution sets in this case as all ordered pairs such that, and you write one of the equations. So I will take the first equation. These infinitely many ordered pairs would be the solution of the system. Now, three equations in three variables. Well, if we have an equation with three variables, this means that we are in three-dimensional coordinate system, x, y, and z. And the graph of such an equation is a plane. And two planes may intersect in a line or may not intersect at all. Three planes, two different planes. If we use the same plane, then it will intersect itself. Three in all the points. Three different planes may intersect in a single point, okay, may intersect in a line, or may not intersect at all. So for such a system, there are also three possibilities, similar to systems with two linear equations. Either we have a unique solution or infinitely many solutions. But infinitely many solutions could be, in this case, one line or a plane, but anyway, infinitely many solutions. And the third case is no solution. And this system is called inconsistent, and this one is dependent. So for example, this is a system and it has a unique solution. You can check that 1, 2, -1 satisfy all the three equations. So actually this is the solution of this system, and in this case it has a unique solution. We will concentrate anyway in this section only on systems with unique solution. We will use left to right elimination method. And let us illustrate this method to solve three systems in three linear equations. We use left to right elimination method. First, we interchange, if necessary, two equations of the system. For example, here I had this is equation 1, this is equation 2. I will interchange equation 1 with 2 to have the coefficient of x in the first equation 1. And that's my goal always. The coefficient of x should be 1 in the first equation, or at least it could be a factor. Okay, it could be a factor of the other two coefficients. So for example, if the coefficient of x here is 4, here is 6, so 2 here would be fine. 1, of course, would be also fine, but in this case, the factor would be also okay. All right, so I have coefficient 1 here, so we interchanged 1 with 2. So now I have x with coefficient 1 in the first equation. That's the first step. The second step, I use this one now, and I add a multiple of the first equation to each of the following equations to cancel the variable x. How? For example, here this is 1, this is 2. So I multiply the first equation by -2 and add it to equation 2. So I do -2 equation 1 times equation 1 plus equation 2, and I write it instead of equation 2. So equation 1 as it is. But now I multiply -2x plus 2x, 0. -2 times -2, 4 plus 4, 8. -2 times -3, 6 plus 5, 11. -2 times 5, -10 plus 4, -6. So I have the second equation after I did this transformation. Okay. Now, how to eliminate x from the third equation? I do the same. I use equation 1. Okay. So I multiply equation 1 by -1 in this case, because this is 1, so I need -1. This is 2, I needed -2, plus equation 3. And by this transformation, the coefficient of x would be also 0 in the third equation, and the coefficients of y, z, and the number will be changed according to this transformation. Now I have the coefficient of x1 and here no x's. So I have this equation or this system. Now what to do? Now I need to eliminate y from the last equation. So how to eliminate y from the last equation? I add a multiple of the second equation to the third equation, so that the coefficient of the second variable, which is y, will be eliminated. To do that, you divide 8y, you have 8y here. You divide by 8 and you multiply by the opposite sign of 5. So -5 over 8. So if you multiply the second equation by -5 over 8 times equation 2 plus equation 3, and you put it here, the first equation as it is, the second equation as it is, you change the last equation using this transformation. Use your calculator. -5 over 8 times 8 would be -5 plus 5. You will have 0 here. -5 over 8 times 7, times 11. -5 over 8 times 11 plus 7. Please check that the calculator will give you 1 over 8. -5 over 8 times -6 plus -4. Please check that the answer is -2 over 8. And now, what do we have? We have the last equation in one variable only, in z only. So we can solve this equation and find the value of z. Once we have the value of z, we can use back substitution and go back to equation 2. And now we have z. Put it here and solve for y, okay? And find the value of y. So we replaced the value of z here and we solve it for y. And again, back substitution. Back substitution and go to equation 1, replace the value of y and the value of z in the first equation and find x to get the answer of this system. And after that, you can check your solution. Let us solve this system using the left to right elimination method. The coefficient of x here is 1, so that's excellent. So what I'm going to do, I will multiply -2 times equation 1 plus equation 2. This will eliminate the coefficient of x in the second equation. I have this -1, so I will just multiply equation 1 by 1. So I will just add equation 1 plus equation 3, and this will eliminate the coefficient of the x in the last equation. So I will have the following. The first equation is not changed, but the second equation, -2 plus 2 is 0, so I have no x. -2 times 2 is -4 plus 3, that's -1. -2 times 3, -6 plus 2, -4. Negative 2 times 6, negative 12 plus 6, negative 6. The third equation, just add x minus x, that's 0. 2y plus y is 3y. 3z plus z is 4z. 6 plus 4 is 10. Now, actually here, I can eliminate the 3 using the second equation, or if you just add the last two equations, you will get the value of z. Okay, so this is as you wish, a special case. Uh, I can add immediately, okay, the last two equations and get rid of z and have y, and then find z and go to the original equation and find x. Although I will use the same procedure of what he mentioned here, so I will try to eliminate y. So we said we do what? The coefficient of y is negative 1, so I divide by negative 1, okay? And I multiply by uh, the opposite of this coefficient, which is negative 3. So in fact, I need to multiply the equation 2 by 3. So I will have 3, I will multiply 3 times equation 2 and add it to equation 3. And this will eliminate the coefficient of y in the last equation. So I have the first equation as it is, not changed. The second equation also as it is. But now I'm going to change the last equation using this transformation. So 3 times negative 1, negative 3 plus 3, that's 0. 3 times negative 4 is negative 12 plus 4, that's negative 8. 3 times negative 6 is negative 18 plus 10, that's negative 8. So now from the last equation, I have z equals negative 8 over negative 8, which is 1. And now I go to the second equation. I have negative y. Negative 4 times 1 is negative 4 equals negative 6. So taking negative 4 to the other side, negative 6 plus 4 is negative 2. Dividing by negative 1 or multiplying by negative 1, I have y. Now I go to the original, the first equation, x plus 2y. Y is 2. 2 times 2 is 4 plus 3z. Z is 1 plus 3 equals to 6. 3 plus 4, 7. 6 minus 7 is negative 1. So the solution set would be an ordered triple. X is negative 1, the x coordinate, the y coordinate is 2, and the z coordinate is 1. And of course, you can check your answer also using the calculator by going to equation, and this time you use the three equations and you enter 1, 2, 3, 6, the coefficients of the first equation, and then the coefficients of the second equation, and then the coefficients of the last equation in the calculator, and the calculator will give you the answer. It will say that x is negative 1, y is 2, z is 1, so our solution is correct. This is the end of this section. I hope you enjoyed the lesson. Study hard and have a nice time.